Welcome back, everybody, for another deep dive. This time, we're taking a look at the sometimes intimidating world of online learning resources.
Sounds a little scary.
Yeah, maybe, but it doesn't have to be.
Definitely not.
No, not at all. We're going to be looking specifically at a website called Open Educational Resources, Open Source Physics at Singapore.
Okay.
And they have just a ton of really cool interactive tools.
Lots of tools out there, yeah.
But we found one that's particularly fascinating called Maximum Measures.
Maximum measure.
Yeah, it's a JavaScript HTML5 applet,
Interesting.
which sounds a little bit like, oh, okay, just another digital ruler on the screen.
Right, I was going to say, is it just pixels on a screen? What are we measuring?
Yeah, exactly. But trust me, this one's got a twist.
Okay, I'm intrigued.
So what's so fascinating about Maximum Measures?
Well, it takes this idea of like measuring things.
Right.
Like you might measure a car in a picture.
Right.
And it uses that to actually teach you about this bigger concept of scaling.
Okay, so walk me through this.
Yep.
Like, what exactly makes this different than me just grabbing a ruler and measuring a photo?
So like imagine you're trying to figure out how long a car is based on a picture.
Okay.
You can measure it on the screen, but that doesn't really tell you how long the car is in real life.
Right.
Unless you know the scale of that picture.
Oh, okay.
So maximum measures makes you think about that relationship between that on-screen measurement and the actual size of the car.
So you're having to figure out, like, what the scale of the picture is?
Exactly. You have to actually estimate and select the correct scale to figure out the real length of the car, and that's where the learning happens.
So it's kind of like those maps.
Yeah.
Where it says like 1 inch equals, however many miles.
Exactly.
And you're figuring that out yourself.
Yes.
Okay.
And that skill, it's not just for maps.
Right.
Think about blueprints for buildings.
Yeah.
Model cars, even like those little tiny plastic dinosaurs.
Okay.
They all rely on this idea of accurate scaling to show the size in a way that we can understand.
That's really cool.
Yeah.
So it's like a real aha moment.
Yeah.
That's cool. So you're not just measuring a still object. You're actually seeing how measurement plays into motion.
Precisely. And by like connecting that visual movement with what you see on the graph,
Yeah.
it helps you understand that relationship between distance and time and speed
Okay.
in a much more intuitive way.
So you can actually see like how different speeds are represented by the different slopes on the graph.
Exactly.
It's a steeper line on the graph
A
means.
steeper line means faster movement.
Okay.
Yeah. So if you cover more distance in the same amount of time,
Right.
that means your speed is higher.
Okay.
And that's reflected in the steepness of the line.
Okay. That's actually starting to make sense now.
Good. I'm glad to hear that.
So it's not just about measuring a still image. It's about understanding how that relates to a moving object and then how that's visualized on a graph.
Yes, exactly.
That's really clever.
I know. It's a really well-designed tool.
Yeah.
And it connects to a lot of real-world scenarios.
Yeah. Give me an example.
Okay, so remember the 2012 London Olympics?
Yeah.
That aquatic center with that really beautiful wave-like roof.
Yeah.
That was all designed using scaling models.
Oh.
And if they messed up those calculations even a little bit,
Yeah.
it could have been a disaster.
Oh, wow. That really puts things into perspective.
Yes.
A tiny error in scale could have real-world consequences.
Absolutely.
So this isn't just like a fun learning tool. It's teaching a skill that's actually really important.
Yes, definitely.
Wow.
And it's interactive.
Right.
It's visual.
Yeah.
It makes it so much more engaging than just like reading about it in a textbook.
For sure.
Yeah.
I think we often take this idea of scale for granted.
We do.
Like we see it in maps, we
Yeah.
see it in models and even in photographs. But we don't always think about like the precision involved.
Right.
And how those things actually translate to the real world.
Yeah. And you're right. We interact with scaled representations all the time.
Yeah.
Like if you double a recipe
Right.
or like a blueprint for a house
Right.
or if you're resizing an image on a computer, it's everywhere.
Yeah, it is. So speaking of digital images,
Yes.
I noticed that Maximum Measures is a JavaScript applet.
Right.
So does that mean you can use it on different websites?
Yeah. That's another great thing about it.
Okay.
So it's embeddable.
Mm-hmm.
So that means anyone who wants to use it can put it on their websites or a learning platform.
So it's not just stuck on this one website.
Exactly.
Cool.
And that just shows how powerful open educational resources are.
Yeah.
Because they're meant to be shared, adapted. You can
Right.
use them anywhere.
Yeah. It's like you're taking a powerful learning tool and you're making it available to everyone.
Exactly.
That's cool. So beyond just the technical aspects of this,
Yeah.
I'm curious about like the cognitive implications of this.
Hmm.
So we're manipulating these like 2D objects on a screen.
Uh-huh.
But how does that translate to our understanding of 3D spaces?
That's a really interesting question. It gets at how our brains work
Yeah,
and how we see the world
right.
and how we understand space.
Yeah, because like we look at a flat map
Yeah,
and somehow we manage to navigate a 3D landscape
it's true.
with hills and valleys and buildings.
Yes,
So there's clearly something happening there.
definitely.
Yeah.
Our brains are really good at connecting those 2D representations to the real 3D world.
So it's like our brain is running a simulation,
It is.
trying to figure out the world based on the information we give it.
Yeah, and maximum measures really helps us understand that process
Okay.
because it highlights how important scale is
Right.
as a bridge between 2D and 3D.
Okay. So it's not just about learning a skill, it's actually developing our spatial reasoning
Exactly.
and understanding how those 2D representations actually inform our perception of the real world.
Exactly.
Wow. That's amazing.
Yeah, and that's something that's important for so many different fields.
Right.
Architects, engineers, artists, anyone who works with spaces
Mm-hmm.
and needs to go from a 2D plan to a 3D reality.
Like that Olympic Aquatic Center.
Exactly.
They weren't just working with lines on paper.
Yeah.
They had to imagine that entire structure,
Uh-huh.
and the scale was crucial.
It's a great example
Yeah.
of how something like scaling can have such a big impact.
Yeah. And the simulation gives us a fun way to start exploring that.
It does.
This has been so interesting.
It has.
I'm really starting to understand just how important scaling is.
Yeah, it's one of those things that's hidden in plain sight.
Yeah.
We use it all the time, but we don't always think about it.
It's like we've uncovered a secret code that unlocks this deeper understanding of everything,
Yes.
from maps and blueprints to even the way our brains work.
It's amazing what you can learn.
And who knew that a JavaScript applet could be so interesting?
Right. It just goes to show that learning can be found anywhere.
Yeah. Well, speaking of valuable insights, I think it's time to wrap things up with a final thought-provoking question for our listeners.
All right. I'm ready.
We've been talking about how this simulation helps us understand scaling in 2 dimensions.
Right.
But I'm wondering how that understanding, or even like a misunderstanding of scale,
Uh-huh.
might affect how we actually see and interact with 3-dimensional spaces.
That's a great question. It makes you think about how we connect those representations to the real world.
Yeah.
You know?
Have you ever gotten totally lost in a city
Oh, yeah. All the time.
just because the map didn't quite match up with what you were actually seeing?
Maps can be tricky.
Yeah.
Definitely.
Or what about those optical illusions,
Oh,
where
yeah.
a 2-dimensional image tricks your brain into seeing depth
Yeah, they mess with your head.
that isn't actually there?
Uh-huh.
Like, it seems like our brains are constantly
Yeah.
trying to reconcile that information from our eyes
Right.
with what we think we know about space.
Mm-hmm.
It's like our brains are running a simulation,
Yeah.
trying to figure out the world.
Constantly updating.
Yeah,
Yeah.
based on all the information we're taking in.
Absolutely. And this maximum measures applet,
Yeah.
it gives us a glimpse into that process
Okay.
by showing us how scale connects those 2D representations with the real world.
So it's not just about learning a specific skill.
No.
It's about developing this spatial reasoning
Yes.
and understanding how what we see in 2D actually affects how we understand the 3D world.
It all connects.
That's amazing.
It is, and it's important for so many different things.
Oh, yeah, totally.
Think about it, architects, engineers, artists,
Yeah.
anyone who works with spaces,
Mm-hmm.
they need to be able to go from a flat plan to a real building or object.
Like that Olympic Aquatic Center we were talking about.
Exactly.
Those architects,
Yeah.
they had to imagine that whole structure in 3D.
They had to get the scale just right.
Wow. So it's a great example of how scaling can have such a big impact on the real world.
Absolutely. And this simulation gives us a fun way to start thinking about all of that.
Yeah,
You know?
it really does. This deep dive has been really eye-opening.
I agree.
It's made me realize how important scaling is,
Mm-hmm.
not just as a math concept,
Right.
but as something that affects how we understand the world around
It
us.
is everywhere.
It's like we've uncovered this secret code
I like that.
that helps us understand maps and blueprints
Yeah.
and even how our brains work.
It's pretty amazing.
And it all started with this little JavaScript applet.
It's amazing what you can learn when you start digging deeper.
Yeah, exactly.
Yeah.
Well, we've talked about how this simulation helps us understand scaling in 2 dimensions.
Yeah.
But I want to leave our listeners with a final thought, something to really chew on.
I'm ready.
We've talked about how this simulation helps us understand scaling in 2 dimensions, but how might that understanding or even a misunderstanding of scale impact our perception and interaction with three-dimensional spaces?
That's a great question. It really makes you think about how we go from a 2D representation to, like, experiencing a real 3D space.
Like, have you ever gotten totally lost in a city
Oh, yeah.
because the map just didn't quite match up with what you were seeing?
Happens all the time.
Yeah.
Maps can be deceiving.
Totally.
Yeah.
Or think about those optical illusions where like a 2D image tricks your brain
Yeah.
into seeing depth that isn't actually there.
Yeah, it messes with your perception.
Yeah. It's like
Yeah.
our brains are constantly trying to make sense of the information from our eyes.
Right.
And our understanding of how space works.
It's like our brains are running a simulation,
Yeah.
trying to figure it all out.
And this maximum measures applet,
Yeah.
it kind of gives us a glimpse into that process.
It does.
Doesn't it?
Yeah.
By showing us how scale
Mm.
connects those 2D representations
Oh,
with the actual 3D world we live in.
it's a powerful concept.
Yeah. So, to wrap up,
Okay.
we've taken this deep dive into a seemingly simple online tool.
It seemed simple at first.
I know, right?
Yeah.
But we've discovered so much
Yeah.
about measurement,
Yeah.
scaling,
Uh-huh.
and even how our brains perceive space.
And it all started with just measuring a car in a picture.
Exactly.
It's pretty cool when you think about it.
Who knew a JavaScript applet could be so thought-provoking?
It just goes to show you that learning can happen anywhere.
Well, we encourage you to check out Maximal Measures for yourself
Yeah, it's a fun one.
and explore the other amazing resources on the Open Educational Resources Open Source Physics at Singapore website.
There's so much to discover out there.
Thanks for joining us on this deep dive.
It's been a pleasure.
Until next time, keep those minds curious.